In this section, we'll discuss the varying ways in which you can query XML. SQL provides us different options for accomplishing that. Which one you end up using really depends on what you need to do with that XML. If you need to select and return relational data as XML, you'll be using the select for XML statement. Conversely, if you have XML data and need a relational representation, then OpenXML is what you'll use. Finally, we're going to take a look at the XML data type, which exposes XQuery methods, making it possible for you to query the XML columns and variables directly. So starting off with that, XQuery is the query language for XML. XML data types support a subset of the XML data type supports a subset of the XQuery language. Variables and columns declared as XML expose this subset of functionality as methods. Those methods are as follows. Query. That gives us the ability to query the XML instance. Value will retrieve a value from the XML instance. Exist is used to determine whether a query returns any results. Modify allows us to do XML data modifications. And nodes will shred the XML into a relational format. However, keep in mind, if you execute these against a null XML instance, query, value, and exist will return nulls. You'd use a query method to issue a query against the XML data type. The syntax is as follows, where XQuery represents the expression for querying the XML nodes. The value method will retrieve the value from the XML instance. Internally, it'll use the tsql convert function and try to convert the result of that expression to a given SQL type. The syntax is as follows, with XQuery being a string literal that retrieves at most one value from the XML instance. The SQL type is the SQL type returned, but it can't be XML. It also can't be a CLR user-defined type, image, text, ntext, or SQL variant. The exist method will return a bit indicating if there are any rows satisfying the query. If it returns 1, that means it's true. 0 means the query generated an empty result set. And nulls returned if the XML instance contains null. Here's the syntax. The XQuery argument is a literal string representing the expression. The modify method takes an XML data modification language statement, and it'll make a modification such as an insert, update, or delete. You'd only use the modify method within the set clause of a tsql update statement. Here's its syntax. The nodes method actually shreds the XML, and it'll return it to you in a relational format. The nodes method returns a result set that contains copies of the original XML. The general syntax for this follows, where once again, XQuery is our XQuery expression, and table column indicates the table and column used by the result set. XQuery has a flower statement, and that's used for iteration. Flower stands for, let, where, order by, and return. A flower statement consists of the following. One or more for clauses, and that'll bind one or more variables to input sequences. Input sequences can be sequences of nodes or atomic values. An optional let clause will assign a value to a given variable. We need an iterator variable, something to allow us to iterate through the nodes. There's an optional where clause supported, as well as an order by clause. And the return expression is used to hold the results. Flower statements are a powerful and flexible way to search XML data. So let's head on over to SSMS and see how it's done. In this example, we're going to take a look at some of the XQuery methods that are exposed when we define a variable or query a column that's of the XML data type. Here you can see we're going to use the query method associated with the XML data type column prod XML. And we're going to take a look at the bicycles XML that we loaded into our example table a little while ago. And what we're doing here is we're saying go ahead and query that document and bring back all of the name elements. We will choose to do that and return the result product name. So let's go ahead and run that. And you can see here we get our XML. I'm going to open that up, and you can see here are all the names of all the products in our XML in that column that is an XML data type. Get rid of that result pane for you, and now we'll move on to the next example. Here we're going to use the value method, and what we're doing is we're saying go search that XML document, go down and find the 5th instance of the product number element. Return that as a varchar 20, and we'll call that the product model. So this is going to go walk that tree, find the 5th element, and return the results. So this is going to go walk that XML document, find the 5th product number, and return the results. And here we can see we have the product model returned. Finally, we're going to use the exist method, and we're going to ask XQuery to go discover whether or not we have a node whose color element contains the value yellow. And if we execute this, we get back a 1. Remember, it's returning a bit, so 1 indicates that that's true. So in our XML document, we have at least one product whose color is yellow. Now let's move on, talk about flower expressions. Here we have a little XML document that contains 3 employees, or contacts I should say, and each one of those contacts has 1 or more phone numbers. And what we're going to do is we're going to create a flower expression to iterate through that XML and return back the number of phone numbers associated with each contact. So here's our XML. Remember, we have 3 contacts. And if I go over here to look at this, we are going to select out of that table the XML and store it in a variable, and then we're going to query that variable, and we just chose to use the variable here to show you that you can use the XQuery methods with variables as well as columns. And we're creating our little XML fragment here using a flower statement, and here we're saying for each contact in our XML fragment, assign to the variable count the number of phone numbers you find for each contact. Order them by count and return this XML fragment. What we'll return is a contact that has a name as one column and the number of phone numbers found for each one of them. So we're going to get back a 2-column result set listing the names of the contacts and the number of phone numbers in that XML. So let's go ahead and execute that. Didn't mean to do that, sorry. Let's go ahead and execute that. We have XML coming back. We're going to open this up, and you can see that we are finding that our contacts, Elizabeth Dallas has 2 phone numbers, Anna Palmer has 2, and Evan Gabriel has 3. And if we go confirm that with our original XML, Elizabeth Dallas had 2, Ann Palmer had 2, and Evan Gabriel had 3. So here were examples of how you can use the XQuery methods for XML data typed variables and columns to query those XML instances easily and straightforward. Now let's discuss the for XML clause of a select statement. It first made its debut in SQL Server 2000, and it was kind of exciting to see it there, but the thrill faded really quickly because the limitations were really apparent. Enhancements have been made since its debut that make it really useful. Some of those enhancements include returning XML with a defined root, the ability to return an XML-typed variable, being able to handle elements that have null values, and returning an inline XSD schema. So let's go over to SQL Server Management Studio and see how we use this clause. Here we'll take a look at some examples of the for XML clause used with a select statement. The first example here is going to select the top 5 rows from our product table, bringing back a few pieces of information. And what we're going to do is we're going to generate the XML. We're going to indicate that we want to use elements, not attributes, and we want to wrap that all up in a root called products. So let's go ahead and do that. And here's our XML result. You can see we have our root products, and we have 1, 2, 3, 4, 5 product elements. And inside we have our individual elements aligning with the columns that we selected in our select statement. So a very simple way of generating an XML result from relational data. Here's basically the same example, except this time we are assigning it to an XML data type variable, and we're going to select that variable back out. Should be no surprise. We have the same result coming back. Just a way of showing you that you can also do that and assign it to a variable and then work with that variable. Here we're going to use an example to go get some items out of our product list again. This time we're going to indicate whether there are null values in some of the columns. So we'll go ahead and execute that. And if we open up our XML, you're going to see here that it's indicating that in these cases the color element is null, or there's a null value in the color column if we want to be a little bit more specific, because we did select this from relational data. But that's a way that we can actually have an indication in our XML that the column that is now being converted into an attribute, or in this case an element, contains a null. And that's kind of nice, some additional info. And finally, let's take a look at how we might generate the schema. We're going to grab a couple of products, again from our product table, and we are going to generate out an XML schema. We'll go execute that. And here you can see is the schema associated with that XML document that's returned as part of the for XML clause of our select statement. So there's our inline schema, and then down here you can see the results. So very flexible, nice way of using XML data, great way of getting some XML data generated from relational data, and we do all of that with the for XML clause of the select statement. The basic syntax for OpenXML is as follows. let's go take a look at some of the details. IDOC is the handle to the internal representation of the XML document, and that's actually prepared by calling the XML prepared document stored procedure. Row pattern, an XPath query used to select nodes. These are nodes that will become rows in the result set. There are flags available which determine the mapping between XML data and the row set. Schema declaration. This will define the relational schema, which in its simple form is nothing more than column names and SQL data types. And then a table name, and this will refer to a name of an existing table in the database. Here are the valid OpenXML flag settings that you can use. This will indicate whether we're going to do things such as attribute or element-centric mapping. Using OpenXML requires 3 steps. First, we have to prepare the XML document to create an in-memory representation of the XML we want to shred. We'll use OpenXML and a select statement to actually shred that XML into a relational form. And then we'll call the XML remove document system procedure to release the resources and destroy the internal representation of that XML. So let's go over to SQL Server Management Studio and use XML to shred a document. In this example, we're going to take a look at the steps necessary to use OpenXML to shred an XML document. The first thing that we need to do is get some XML loaded into an XML variable. And here you can see we're declaring one here. This is our document, and we're actually going to select some XML out of an existing table. Then the first thing that we need to do once we have our XML ready to be shredded is we have to prepare that document. And what the XML prepare document system procedure does is takes in that document that we want to shred and returns to us a handle. Once we have that handle, we can then go and use the OpenXML function, passing it in the document handle, passing in what we want to search by. Here we're going to look at all of the bicycles, all of the products that are in our bicycles list, and we're indicating here with this flag that we want the results to be element-centric. We're going to return elements, and we're going to return them in these 2 columns. We're going to grab the name and the product number, and when we're all done with that and have executed that and received our data, then we want to clean up. And what we need to do there is simply execute the XML remove document system procedure, pass in the document handle received at the beginning, and that'll clean up all the resources. So again, the steps are pretty straightforward. We're going to get our XML document. We are going to ask it to prepare that, get a handle to it so that we can reference it. Now that we can reference it, we'll use OpenXML. We'll indicate in that OpenXML the document handle, what we want to search, and optionally some flags to indicate how we want the results returned. And then we're going to give it a structure. How are we going to lay out the columns that we want returned in a relational format, and then release all of the resources. So given that, let's go ahead and execute this. And we should see some columns coming back. And sure enough, our XML data has been shredded and returned as a relational representation, and we now have a way of not only taking relational data and making it XML, but taking XML data and returning it as a relational representation.